So far in Chapter 6, you've learned how to solve linear systems using graphing, which creates a nice visual, substitution, which is helpful when we have one variable isolated, and also elimination when an equation is written in standard form, and especially when we have matching coefficients. For Lesson 6.4, we're going to work on a few different types of word problems where we're going to be solving linear systems, applying the different strategies that we know. The first type of problem is called a break-even problem. So let's read the word problem. It says that a fashion designer makes and sells hats. So they're making money, they're making it, so they're spending money, and they're also selling the hats, so they're making money off of that. So we're going to have an equation for both situations. The material for each hat costs $5.50. So just to make the hat, each hat costs $5.50. The hats sell for $12.50. So it sounds like the designer is making $12.50 off of each hat. The designer spends $1,400 on advertising. So that's another expense to include. We want to know how many hats must the designer sell to break even. So we need to identify our variables. Let's say X is each hat. So it's going to be the number of hats. Y then will be the total cost. All right, the expense equation, the money that the fashion designer has to spend, includes the money per hat and this initial fee. The initial fee we know is going to be our y-intercept, so we can say we have y is equal to $5.50 per hat plus that initial fee. Then we also have the money that the seller is going to make, or the income. The designer is going to make $12.50 on each hat, so we can say the total cost, or the total amount of money, is going to be equal to $12.50 per hat times X. Now we have two equations representing our situation. Again, it's a system, so we need two equations, and we have a variable isolated for each. So we're going to use substitution and take this part and substitute it in for y. So then we have $12.50 X set equal to the rest of that equation, $5.50 X plus 1,400. And we can solve this equation. We want all the variables on the same side, so we're going to subtract that on both sides. $12.50 minus $5.50 leaves us with $7 even, set equal to 1,400. Divide by 7 on both sides, and we get X is equal to 200. Again, X represented hats, so we can label it. And the question we were trying to solve was how many hats must the designer sell to break even? 200 hats would be that answer. We could also figure out, though, how much money would have to be spent before they break even by plugging this back into either one of the equations. I'm going to pick the bottom one just because it's less steps. So we would say that y is equal to $12.50 multiplied by 200. And when we multiply that, we get 2,500, and y represented the total cost, so we would have money as our label. Again, we would need to sell 200 hats to break even at $2,500. Let's try the next example. This time we're talking about puzzles. Again, we need two equations because we're solving systems of linear equations. A puzzle expert wrote a new Sudoku puzzle book. His initial costs are $864. Binding and packaging each book costs 80 cents. So So we know that Y, the total cost, or the expense of making the book, can be written as Y is equal to, if it's 80 cents per book, we need a different variable, so we'll use X. X then represents the number of books, plus that initial cost of $864. Then it says that the price of the book, when they turn around and sell it, is $2. So we know that the income that the puzzle expert's going to make off of the books is $2 per book. So we can say the money, Y, is equal to $2 per book, X. Again, we have two equations, and our variables are isolated, or one of the variables is isolated, so we can use substitution. We're going to take this piece and substitute it in for Y, because it has the same, it's equal to Y. So now we have 2X is equal to 80 cents X plus 864. And then we can solve that equation. Divide by 1 2/10, leaving us with X is equal to 720. X again represents books, so we can label that. We wanted to answer the question of how many copies must be sold. Well, 720 copies of the books would need to be sold. Again, we could figure out at how much money would need to be spent by plugging that 720 back into either of our equations. This equation looks easier to me, so I'm going to use that one. 2 times X, which is 720. And when we multiply that, we get 1,440. Y again was the cost, so that would be dollars.